After setting up Wazuh on your home lab, what next? Most people just look at the alerts and do nothing else. But what if I tell you that you could actually write your own detection rules as a good security engineer or SOC analyst? In this video, we are going to see how to write detection rules in Wazuh. We are also going to explain the different fields in the detection rules. And I'm also going to show you a live example of writing a detection rule and also adding it into your Wazuh server. If you're new here, this is SecGen. We deep dive into cybersecurity knowledge and work on hands-on lab. Join us as we go on.
All demonstrations in this video are performed in a controlled lab, environment for educational purposes only. Do not attempt these techniques on networks or systems you do not own or have permission to test.
So what I kind of did was that I created a slide deck that explains the detection rules and an effective guide to understand what detection rules are. This slide deck just gives us an example and explains the different fields of a detection rule. But before we start up, let's kind of understand what a detection rule is. A detection rule is a simple logic that tells Wazoo when you see this pattern, raise an alert. Logs by himself. So all the logs that we get from our firewalls, our ADs on their own, don't mean much without detection rules. Simply put, in a real SOC, detection rules are what analysts actually rely on to identify attacks. And us understanding Wazoo detection rules is critical for effective security monitoring. And also, these rules help identify suspicious activities that happen in whatever environment that we have, be it our home lab or in production, actually. So let's go into an example straight up. Right here, we could see a detection rule. First off, what do we see here? We see row, we see the ID, the level, if seed, and the field and the description. Each of this actually means something in the grand scheme of things on writing an alert or a detection in an environment. So let's go in and actually see what this is. First, we are going to look into ID, and the ID is just the unique name of the rule. Every rule needs one, and other rules can refer to it. So the ID, every rule in Wazoo needs an ID, and each ID cannot be the same ID for each of them. One other thing we can also see here is that the rules. One other thing is that the level cuts this part off. One other thing is that we could see SID as a way to communicate to a specific rule that has been written already. We're going to see that as we go on in this video. Next one we kind of see here is the alert severity. The alert severity, it shows either it is critical, high means priority, high risk, cut. The level also determines the severity. High level means high priority, high risk, more attention is needed for that specific alert. In the real SOC, this helps analysts to decide what to investigate first. I'm sure we all know that already. But as we go on, let's see the next one, which is the if seed. This part is very important. So this rule doesn't detect failed login itself. It only runs if another rule has already detected a failed login. So let's say if this rule basically is telling us that if a failed login happens and the account is like an administrative account, raise a higher severity alert. This is called rule chaining. So we are going this rule chaining is part of things that happen with detection engineering and writing detection rules. Next, we are going to go into is the field. The field filters the event. So instead of alerting on every failed login, we only alert when a sensitive account is targeted. This reduces the noise. So if you see in the like some slides back, let's actually go some slides back to understand what this means. So we could kind of see here saying field name equals to win event data target username. So this is the username we are targeting for the alerts. And the username that we're targeting for the alerts here, we see is the administrator. So this makes a little bit more sense on what we are doing here. The next one is the description. So the description in a nutshell is just what the analyst sees when the detection fires. So it says the description is just what the analyst sees, literally. That is the easiest way of breaking that down. So what I actually did was that I created a Git page that has all the detection rules I'll be using in this series of videos I'll be making. So for today, this is the detection rule page. I'll be adding it into the link in the chat when I post the video. But you could see I created for one for Linux and one for Windows. And we are going to be working on the one for Linux today. The one we are going to be working on Linux is the SSH brute force detection rule. What detection rule is that? The rule ID is going to be 57110. The category for that is authentication failure. So we're going to look for more authentication failure. And the purpose of this is for us to be able to detect repeated failed SSH login attempts originating from the same IP address over a certain period of time. The use cases is like Linux server exposed to the internet are frequently targeted by SSH brute forces, right? Attempts. So you would want to know if those SSH brute force attempts affected or even got access into your network. So one thing we're going to kind of do now is that we're going to create more series on how to actually detect that. The simulated scenario we're going to look at today is an attacker uses a tool such as Hydra. So on my Kali Linux, I have Hydra. We're going to attempt it and kind of see how it's going to, what is going to provide for us as our logs. Within, let's say, like within 45 seconds, multiple failed login attempts are generated from the same IP address. We are going to get an alert for that. What is the rule logic we are using today? So this is the rule logic. Let me make this a little bit bigger so we could kind of see what the rule logic is. So this is the rule logic I'll be using today. So the rule ID, as we spoke about, each rule has to have a unique ID. The level means criticality. So we have a 10, which is high. The if said is it's related to the normal authentication log. So with authentication, field authentication, so we are saying if there are enough field authentication within a specific period of, like, we are going to use the frequency as 6 seconds for the frequency of 60 from the same IP address, we should send an alert saying brute force SSH brute force attack detected in your environment. Now we are going to go into my Proxmox server to kind of see what we are working with. First off, this is my Proxmox server, which has all my devices in here that are connected to my Wazuh SIM. The target today is going to be my Nessus um, server. So I have a Nexus server in my lab here, but that is what we are going to be using as our test subject today. One first thing first is that we are going to add the Wazuh rule here. So where do we add this Wazuh rule? This is where we add the Wazuh rule in our server. We have to go to var, osec, etc, and rules. That is where we have, if you click on ls, that is where we have the local underscore rules.xml. The local rule XML is on a normal day, Wazuh already has rules that are being already put in there for us already. But with this actually helps us to create rules that we want in our own SIM environment. At the moment, I kind of have some personal ones that I've already written before. Let's look at those ones and kind of see how they are. So we kind of see here, I kind of wrote some rules for authentication failed. and also added so an account added to the local administrator group, possibly privilege escalation. So if an account is being added to if an account is being added to the administrator group on my domain controller, I get an alert saying that that account was added. So I will go in, investigate if it's me that set up that account or added that account to the administrative group. Yeah, is a true negative. So good. Let's now see how we could add our rule in here. One thing first that we're going to kind of do here is that I have to come in here to the Wazoo rules because I do not want to. This is the easiest way for me to have access to. This is the easiest way for me to have access to my repo from in here because I want to do it from inside my lab. So let's go to Linux. We go to SSH brute force brute force. So we'll copy the rule that we want to use. So this is the rule I want to use now. So this is the rule that we are going to copy. I'm going to copy this rule, copy this, come back into my command line. I always kind of just take some space down and I just actually just paste. So good. So we could see now that this is the rule ID, the level, um, the if seed. So this is connected to another ID that shows this, the frequency, and the time frame is shown here. So we are going to control X, yes, save. Then we are actually going to system CTL restart our Zoo manager service. So we need to restart our Zoo manager service. Perfect. Okay, so you see, I actually have an error here. So I have to kind of figure out why I have an error here. So actually, what happened was that, let me show you this. So you always have issues like this when you are running when you are setting up rules. This is one thing that I would always respect and I would not want anyone to go through. So if you see here, my Wazoo server failed to start. The reason why this failed to start is if I come back here and look at the rule I did, the rule ID one may another rule may have this rule ID at the moment, and the if seed may not be correct. So what I'm going to do is that I have kind of ran this in the past. So I'm going to come back into my server, into threat hunting, my Nexus, and go into not the past 24 hours, show data for let's say 3 days, and update. Good. So I'm gonna click on SSH ID. Okay, good. Authentication failure ones. Yeah. Those are the events I want to see. I want to see the event ID. So you see the event ID for this is 5760. Let's see this 5760. So this is meant to be 5760. So when copying this now into my Wazoo server, let's try this again one more time. 5660. And also, I'm actually going to put it like this. I'm going to make my ID just one more number. And let's see what this is again. 5760. Good. So 5760. Good. So Control X, yes, buffer, enter. Then let's restart Wazuh. Let's see if it's going to work. Literally, cybersecurity is not just all fun and games. You're always gonna have issues like this on the side. So you see, we are still seeing see for the error. Okay, good. Uh, Let me see. Joe identifier failed to start. So good. This fails to start. Let me look into this one. I'll come back. So we are back with the video. I'm gonna explain to you why the first one did not work. So let me go to my Kali box and show you one or two things that I see related to the detection I wanted to run and why it didn't work. First thing we kind of see here is that we already have a detection that shows that already. So it shows SSH, the brute force trying to get access to your system authentication failed, right? Good. With that already set up already on the back end, it is not use that same or to create the same detection rule would not work. So what did I do on the back end? I created a new detection rule um that we would show. So the new detection rule I created is this. Let me bring that up here. Good. Let's explain it or let's break this down easier for us to understand. So it's showing 5760 is the failed authentication. Um, if it matches root, so if the attacker uses any account name root, we are going to create an alert for that. So let's see how that works. Just give me a minute. Let this load up. So I actually do have a word list here that we could actually use. Just give me a minute. Let me get the word list out. So perfect. So this is the word list I'm using. So in between somewhere here, I'm going to add roots. So I'm going to use it's going to actually alert for every single one of them because the username we're going to use here is root. So good. So I'm going to use Hydra for this. Let's see how that works. What I'm going to first do is I'm going to make sure that we have going to make sure that we have Wazuh showing us we going into the logs for this threat hunting logs events. So we are going to be on this event page and see what happened while we run this again. So I already know my Nexus box, the IP address. So I'm going to run this and let's see what happens. It's not going to gain access because none of them are the passwords. But let's refresh this page and see what happens here. Good. We could kind of see that the SSH failed login attempt from root account shows here. So this kind of shows that the alert is working. So The last rule that I tried, I could not use that because Wazuh has already created a rule like that. So what I did here was I created a rule that says after this 5760 reaches the field login, says send an alert which is level 12 alert saying SSH brute force attack detected, high severity custom rule. So let's see how that works when we run it here. So we're going to use Hydra. We are going to use Hydra to run it here. Let's try that now. If we run it here, Hydra will go through the list that I provided for of passwords I provided for them. And let's refresh the page here to see which alerts actually populates here. Let's see which one populates here. Good. So you could see the custom alerts which we created is showing here with the rule ID that we created here. So in general, this is just how we create rules. You could see, yeah, literally the whole description and how it breaks down the description and where it gets information from for the description for the detection. So this is the first video in a series of understanding detection rules. I am going to go through my mistakes at the same time with you guys. Please tune in next time for the next content we're going to have related to security engineering and detection engineering. See you guys on the next call.